Good afternoon, students. Today we are going to discuss the last week assignment. So, the MCQ questions from Simple Kinetic Molecular Model of Matter, Part 2. So, I'm not going to discuss all the questions now, like almost all the questions, but like I'm omitting a couple of questions which are repetitive, like same idea. So, let's look at the second question. If you haven't read the question, pause the video and read it. So a bubble of gas is formed and it has a volume of 40 centimeter cube. The pressure is P. Now the bubble rises up through the water. The volume of the bubble increases to 56 centimeter cube and the pressure becomes 100,000 kilopascal. The temperature is kept constant. Initial pressure, you have to apply P1 V1 equals P2 V2. You just have to apply P1 V1 equals P2 V2. Initial pressure times initial volume equals to final pressure times final volume. So the initial volume is 40 centimeter cube, and even if like the water is it's coming about like towards the surface, so the volume should increase, and it is increasing. It is 56 finally. Final pressure is 100 kilopascals, so kilo is 10 to the power 3, but there are answers in kilopascals as well, so I'm not converting it to pascals, I'm just keeping it like that. And P1, so if you calculate P1, it would be 56 over 40 times 100 kilopascals. Now that's going to be it's about 140 kilopascals, right? Then fourth question, which row, okay, read it if you haven't read it. So we are comparing a hot gas and a cool liquid. The pressure is same. So separation in a gas, obviously separation will be greater and the gas molecules moves faster. So the answer is A. Fifth one, so the only issue with this question, the only mistake that you could commit is you might take this, it's decreased by 15 centimeter cube. That means the final is 25 minus 15, so 10 centimeter cube. You might take it as take the 15 centimeter cube as the final temperature. Look here, it says decreased by, it is not saying decreased to. Okay, so be careful about that. So then the rest of the question is easy. If you haven't made that mistake, the question is quite easier. So and there is also another possibility of a mistake, so you need to be careful. So let's consider the P1 is equal to 100 kilopascals. Since the answers are in kilopascals as well, I'm not converting it. The four answers are all given in kilopascals, so I'm not converting it to pascals. Initial volume is 25 centimeter cube. The final volume is 25 minus 15. It decreases by 15, not decreases to 15. So 10 centimeter cube. It happens in constant temperature. So first let's calculate the final pressure. So P1 V1 equals P2 V2, initial volume, initial pressure, final volume, final pressure. So 100 times 25 equals P2 times 10. So P2 is going to be 250 pascals. Again, there's a possibility of committing a mistake. Now if you look at the answers, in the answer this 250 pascals is also given. So if you look answer D, then the answer D is 250 kilopascals. But the question is again the change in pressure, not what is final pressure. So the pressure has gone from 100 to a final value, as we calculated, 250. So the change is 150. So the physics is same. Now this question number 5 and that question number 2, it's fundamentally the same question, numbers different, and there is a bit of a distraction here. You might forget the word change. Okay, so but physics, as far as physics is concerned, both are the same question, so you just have to be careful. In question number 6, a stationary smoke particle. Read the question, pause the video and read the question if you haven't. So we know that the smoke particles will move. That's why the zigzag movement is created in the Brownian motion. But obviously it's a collision, so there is a zigzag movement of the smoke particle. At the same time, what will happen to the nitrogen molecules if two things collides? Most probably they will rebound and give it, right? Yes, in a classic situation, that like in a day-to-day situation, there is the possibility of one of the object involved in the collision coming to rest, but you need to be careful that this is a nitrogen molecule, it's a gas molecule. So have you ever heard of a gas molecule being at rest? No, right? So it's bound to collide, like rebound. It's bound to rebound. Okay, so yeah, so the answer is 6. The question answer is A. The 9th question. Now this might make you scared, but don't be. So they are basically, now earlier they were testing your knowledge of P1 V1 equal P2 V2 by giving numbers. Now they are testing the same thing by a graph, by giving the pattern of a graph, right? So what we know is that all of these are pressure versus volume graphs. What we know is that the initial pressure times volume will be equal to the final pressure times volume, right? That means if P2 is greater than P1, then V2 must be less than V1. The product of two numbers are equal. So let's take 50 into 4 is equal to 200. Now if that should be equal to 100 into something, now if 50 is becoming 100, if it is increasing, then the other number should decrease, right? So if the second pressure is greater than the first initial pressure, then the second volume, the final volume, should be less than the initial volume, right? So that is the only information you need. If you look at all these graphs, all these frightening graphs, they are not really frightening. One has to face his fears. Well, I'm watching the movie Divergent, so that's why I'm talking in that language. So if you face this graph, the pressure is increasing, fine. But when the pressure is increasing, if you look at the volume is also increasing. Now consider a point in pressure. This is my P1. The corresponding volume is here, V1. So P1, V1. Then if I consider another pressure which is greater, if I consider another pressure value, oh, it's gone. So this is P1 V1. Then if I try to consider, what's wrong? Here. Then if I consider another value, P2, the corresponding volume value V2. Now V2 is obviously greater than V1. V2 is here and V1 is here. So when the pressure is increasing, the volume is also increasing. Now that's not possible. As long as the temperature is kept constant, that cannot happen. And it is said here very clearly that the temperature is kept constant. Right? So that's not possible. If you look here, the pressure is kept constant as well when the volume is increasing. No. When the volume changes, pressure should also change accordingly. If the volume is decreasing, here the volume is increasing, that means the pressure should decrease. But here the pressure remains constant, so that's also not possible. If you look here, again the same idea. When the volume increases, pressure is increasing as well. So P1, the corresponding V1, but if you consider P2, the V2 is also greater than that. So just that one condition is enough for you to find out that the answer to this question is D. In D only, if you look, in D only, the value of pressure is decreasing. So this is our the value of so this is my P1 and this is my V1. Then I consider a P value which is greater than P1. The P2 is greater than P1, but then I have a V2. Now V2 is less than V1. That's fine. When P2 is greater than P1, when pressure is increasing, volume should decrease. So just that idea is enough to solve this question. But if you want, you can also use your mathematical knowledge. I don't know whether you have studied these graphs. Now you know that y is equal to mx plus c is a straight line through so it's a straight line with an intercept. Similarly, if there is a graph of the form xy is equal to constant, so xy is equal to a constant, then it would follow this kind of a path. Okay. So you can, so here basically P1 V1 equal P2 V2. Now that would be equal to P3 V3. That would be equal to P4 V4. That is basically PV is equal to constant. So x y equals to a constant. It follows this shape, and you can use that idea as well. But if you are not sure, don't be worried. Just this idea is enough.